Hello learners. Previously, lesson 5 in form 3, we were dealing with diffusion. In lesson 6, we are dealing with rates of diffusion of gases. So, rate of diffusion of a gas depends on two factors. One of the factors is density, and the other one is the molecular mass, a relative molecular mass. So, we are saying gases with low density or low molecular mass diffuses faster than gases with high density or bigger molecular mass. Okay, let's do example. We are having a setup here. We are told study the setup below and answer the questions that follow. So here we are having a glass tube, and here we are having cotton wool soaked in concentrated ammonia solution. On this other end, we are having cotton wool soaked in concentrated hydrochloric acid. Okay, in this side, we are having cotton wool soaked in concentrated ammonia solution. So concentrated ammonia solution generates ammonia gas. So that ammonia gas diffuses because it's a gas. On this other end, we're having concentrated hydrochloric acid, which generates hydrogen chloride fumes or hydrogen chloride gas. It's also a gas, it's going to diffuse. So those two gases, they are going to meet at a point. So to go to the question, we're told, after some time, a white ring is formed. So how will this white ring come? It will come when that ammonia gas, which is generated by the concentrated ammonia solution, gets in contact or reacted or combines with the gas, that's hydrogen chloride fumes or gas that has generated by concentrated hydrochloric acid. So which product, we are told name the white ring, which product will be formed when ammonia gas reacts with hydrogen chloride gas? We are going to get ammonium chloride. So we are going to get ammonium chloride. Ammonium chloride. So that is the name of the white ring. Okay, thereafter, we are told write an equation for the formation of the white ring. We are told write the equation for the formation of the white ring. We have said concentrated ammonia solution generates ammonia gas. So ammonia gas is written NH3. It will react or combines with hydrogen chloride gas, which has been generated by the concentrated hydrochloric acid. So they are going to form ammonium chloride. How do you write ammonium chloride? It's written NH4Cl, and it's a fume. So we're having a gas. So this equation, you have to balance it, and it is self-balanced. Okay, lastly, we are told in which part is the white ring formed. So that means from the setup that you have seen, we're having two ends. In this side, we are generating ammonia gas. In this other side, we are generating hydrogen chloride gas. So we are dealing with the rate of diffusion. Which one will be faster, and where are they going to meet? So for us to know that, we are told density and molecular mass are the factors that depend on diffusion or the rate of diffusion of gases. So let us see, first of all, the relative molecular mass, the molecular mass of ammonia and that of hydrogen chloride gas. So the molecular mass for ammonia is N, which is 14, that's nitrogen, plus 1 times 3, which is hydrogen. This will be 17. What about hydrogen chloride fumes? We're having 1 for hydrogen plus 35.5 for chlorine. So this is 36.5. So check which one is having a low relative molecular mass. That one is the one that diffuses faster than the other one. So here we can see ammonia is having 17 and hydrogen chloride gas or fumes is having that 6.5. That means ammonia diffuses faster. So if you see now the distance here, let's just assume this is the center. If this is the center, that means ammonia diffuses faster than that hydrogen chloride gas, so it will pass the center. So and meet this hydrogen chloride somewhere here, maybe somewhere here. So we can have a ring. If we are told maybe write or draw a ring, something like that. But here we are told in which part. We are told in which part is the ring formed. So we can say it is formed near the cotton wool soaked in concentrated hydrochloric acid. That's our answer. So we are saying near the cotton wool soaked in concentrated hydrochloric acid. Remember, we are told, give a reason. Why is it formed near the cotton wool soaked in concentrated hydrochloric acid? So the answer is because ammonia has a low molecular mass, hence diffuses faster than hydrogen chloride gas, which has a bigger molecular mass. So I'm saying this is because ammonia has a low relative molecular mass, has a low relative molecular mass, hence diffuses faster than hydrogen chloride gas, which has a bigger relative molecular mass. So that is your answer. We are told in which part is the ring formed. Is the white ring formed? So we have said near the cotton wool soaked in concentrated hydrochloric acid. Reason? This is because ammonia gas has a low relative molecular mass, hence diffuses faster than hydrogen chloride gas, which has a bigger relative molecular mass. Remember previously we have said gases with low density or low molecular mass diffuses faster than gases that have high density or bigger molecular mass. Okay, thereafter we are going to go to question 2. We are told in an experiment the distance covered by gas X is 12 centimeter, while the distance covered by gas Y is 8 centimeter. Within the same time interval of 5 minutes. So I told calculate the rate of diffusion of gas X. So before we calculate the relative rate, before we calculate that relative rate of diffusion of gas X, let's first of all know these two gases, which one is diffusing faster? Let's check first of all. So the first one, X, is covering 12 centimeter in 5 minutes. The time is equal. But that gas Y, it's taking now 8 centimeter. 8 centimeter. It's taking 8 centimeter. So to see these two, which one is the one that's having a high rate of diffusion? It will be the one that's covering a higher distance. That means 12 centimeter in 5 minutes. So that means Y is faster than, X is faster than Y, because it is taking a longer distance, that's 12 centimeter within 5 minutes, while this Y is taking 8 centimeter in that 5 minutes. So here we can see gas X is the one that diffuses faster. Okay, let's now see the rate of each. Let's start with rate of diffusion of gas X. So rate is given by, we can get by rate by distance over time. We can get distance over time. So in our case, we are having 12 centimeter as the distance covered by this gas X, divided the time, that is 5 minutes we are having here. So what are we going to get this? So we are going to have 12 divided by 5. We are going to get 2.5. So what is the unit? It will be centimeter cube per minute. Centimeter alone, because we are having here distance, not volume, sorry. Then what about the other one? So we are going to get rate of diffusion of gas Y. It will be the same distance, which is 8 centimeter covered by that gas Y, divided by the time taken, that is 5. So what are we going to get there? 8 divided 5. 8 divided by 5, we are going to get 1.6, so centimeter per minute. Okay, let's get the relative rate. So we are asking now how many times that gas X faster than this Y. So we are going to have now relative rate, rate of diffusion of gas X divided by the rate of diffusion of gas Y. Okay, if we write this, we are going to substitute with what we have gotten there in the relative, the rate of diffusion of gas X. We have gotten 2.4 centimeter per minute. So we say 2.4 centimeter per minute, then divided by the other side, the rate of diffusion of gas Y, which is 1.6 centimeter per minute. So learners, centimeter per minute, we'll go with centimeter per minute. So what are we going to get when we take 2.4, then divided by 1.6? So there we are going to get 1.5. So here we are going to get 1.5. So this one has no unit because centimeter per minute has gone with centimeter per minute. So what does this mean? This means gas X diffuses faster than this gas Y by 1.5. So we can say gas X diffuses 1.5 times faster than gas Y. That's what we're going to say. Therefore, that's our conclusion. Therefore, we are going to say gas X diffuses 1.5 times. Gas X diffuses 1.5 times faster than gas Y. That's our conclusion.